Okay, now the big table. You're going to have to complete the following table here, and you're going to do something like this also on your exam. I've written on all the names in red, so you can check those out. I'm going to work out the charges, the ratios, and the formulas with the pen here. So we've got sulfur, or sodium bonding with sulfur. So sodium is your metal, that always comes first, and that's going to be your cation because it's positive. So it's going to be +1. Sulfur, you have to look up what group it's in. It's in group 6, so it has 6 electrons already. It needs 2 more, so it's going to gain 2 and become -2. Crisscross the charges, or just think about it logically. You need 2 sodiums to get 1 sulfur happy. They each need to give up an electron. Here's the other sodium. I'll write it in. So you're going to end up with 2 sodiums each giving up 1 to make the 1 happy, so it's going to be a 2-to-1 ratio. And if you write it out in chemistry terms, it's Na2S, and that's sodium sulfide. Remember, ide is the sulfur right off the periodic table. There's no sulfate here. No oxygens bonded to it. We'll get to that next. Alright, we got potassium and sulfate. Potassium's +1. Sulfate, you needed to memorize or look up, and it's SO4 -2. Again, same situation. Potassium can only give up 1. Sulfate needs to get 2, so you need 2 potassiums. So they're going to bond on a 2-to-1 ratio. In chemistry terms, we write it K2 and then SO4. And I don't use parentheses around SO4 because there's only one of them. There's only one in the ratio, and that's potassium sulfate. Alright, aluminum and nitrogen. Nitrogen right off the periodic table, so it's going to be aluminum with a +3 charge, and then nitrogen's going to be -3. This one's giving up 3 electrons, this one's taking 3. One of these makes one of these happy, so we're going to ignore those little charges. We're just going to write ALN, aluminum nitride, ide off the periodic table. Now we have nitrate. Aluminum, in this case, is still going to make a +3, but nitrate is going to be different than nitride. Nitrate is NO3 -1. How do I know that? I look it up. One aluminum's given up 3 electrons. Nitrate can only take 1 each, so it's going to be 1, 2, 3. We're going to have a nitrate here, and a nitrate here. 3 nitrates because they can each take 1, and then it's Al, crisscross the charges, NO3, and then put that 3 down here from the aluminum, and the imaginary 1 goes down here, and then we don't want 33 oxygen, so we put nitrate in parentheses. And that's aluminum nitrate. Now the next one, iron 3. This is great because it makes your life easy. You don't have to think about what iron's charge is. It's given to you right here. So this is a +3, and oxygen is right off the periodic table in group 6, so it needs 2 more electrons. Crisscross your charges. You're going to end up bonding on a 2-to-3 ratio, and it's going to be Fe2O3. Calcium and phosphorus. Calcium's +2. Phosphorus is P-3. Notice it's not phosphate, it's just phosphorus right off the periodic table, so the ending of the name is going to be phosphide. Crisscross these guys, it's going to be a 3-to-2 ratio, Ca3P2. Alright. Gallium. Gallium makes a +3 charge. It's under aluminum, so it does the same thing. And carbonate, you have to memorize, CO3 -2. Crisscross the charges there. They're going to bond on a 2-to-3 ratio. And here we go. Ga2CO3 3. I got to put carbonate in parentheses. Strontium. Strontium's +2. Little hydroxide is -1. It can only take 1. This one's trying to give up 2. Little hydroxide saying, wait, I can only take 1, but I'll go find a friend, so there'll be another hydroxide. So it's going to end up bonding on a 1-to-2 ratio. And then when I write this out, Sr with the imaginary 1 from the hydroxide, and then we write OH, and then we put the 2 down here from the strontium. Now we don't want to say we want 1 strontium, 1 oxygen, and 2 hydrogens. We want to show that we want 2 sets of OH. So 2 O's, 2 H's. So we got to put the OH, the whole package you studied, goes in parentheses. And then finally, magnesium and phosphate. Magnesium's +2. Phosphate, hopefully you've studied that and know it's PO4 -3. Crisscross the charges and figure out your ratio, and then write it in chemistry terms, Mg3 PO4 2. Now we don't want 42 oxygens. We want 2 sets of phosphate. So put whatever you studied in parentheses. Okay. All right, let's move on to the next section.